In this video, I'm going to combine the remainder theorem and the factor theorem. So the remainder theorem says that if we have some function, let's call it f of x, okay, and if it's being divided by some linear factor x minus a, then this means that after we divide the function f of x by x minus a, the remainder, that's going to equal the function f of x evaluated at a. Okay, so if we had some function, 3x squared minus x plus 5, right? That's our f of x, and we're dividing it by, let's go x minus 2. Then the remainder, we'll call it r, is going to be equal to f of 2, right? Because if x minus a is our linear factor we're dividing by, then x minus 2, in x minus 2, then 2 is going to be our a, right? Because x minus a, x minus 2, 2 is our a, so the function evaluated at 2 is going to be our remainder. So if our function is 3x squared minus x plus 5, right, f of 2 is going to be equal to 3 times 2 squared minus 2 plus 5. So everywhere I see an x in our original function, right, I'm just plugging in 2. So 3 times 2 squared, that's 3 times 4, so that's 12, minus 2 plus 5. Okay, 12 minus 2 is 10, plus 5 is 15. So the remainder, when we divide 3x squared minus x plus 5 of our function, is going to be equal to 15. Okay, and the factor theorem says that if it's kind of a similar theorem, it's using the remainder theorem, but it's just kind of going one step further. It's saying if we have some function f of x, we're dividing by a factor x minus a. X minus a is a factor of the function f of x if the remainder is equal to 0. Okay, so I'm going to think of an example here. Let's say, let's think of our own example right now. So let's say we had like x plus 2, x minus 2, so this will be, so this will be x squared minus 4. Okay, so let's say x squared minus 4 is our function. Okay, so x squared minus 4 is our function, and let's say we're dividing by x minus 2. Okay, so remember the remainder of this will be equal to f evaluated at a. In this case, a is 2. Okay, so if we plug in 2 for x, right, x squared minus 4 is our function, so f of 2 will just be 2 squared minus 4, which is 4 minus 4, which is 0. So anytime you're dividing the function x squared minus 4 by a factor, which is x minus 2, then your remainder is going to be 0. This would also work for positive 2. So let's say we were dividing by x plus 2, right? Then in this case, our a is going to be negative 2. So the remainder of this is going to be the function evaluated when x is negative 2. So remember, f of negative 2 is going to be negative 2 squared minus 4, which is also 0. So that must mean that x plus 2 and, or I won't put plus, I'll put an actual and sign, and x minus 2 are factors of f of x. And that just means when we divide f of x by either x plus 2 or x minus 2, we're going to get 0 as a remainder. So there's nothing that's going to be left over. It's going to divide perfectly. Okay, so that's kind of the remainder and the factor theorem. So let's go over some examples. Find the remainder. Okay, find the remainder when x cubed minus 2x squared plus x minus 1, okay, that's our f of x, is divided by x plus 1. So x plus 1 is our linear factor we're dividing by. So when it's x plus 1, remember our a value is going to be minus 1. So the remainder is going to be equal to the function f of x evaluated when x is equal to negative 1. because we're dividing by x plus 1, that means that our x value is negative 1. Okay, so f of negative 1, we're just going to put in negative 1 wherever we see x in this function right here. Okay, so negative 1 cubed minus 2 times negative 1 squared plus negative 1 minus 1. So negative 1 cubed, that's negative 1 times negative 1 times negative 1. So that's negative 1 minus 2 times negative 1 squared. Negative 1 squared is positive 1. And negative 2 times positive 1 is negative 2. Plus negative 1, that's just the same as minus 1. And then we have minus 1 again. So we got minus 3 minus 1 minus 1, so that's minus 5. Okay, and in my last video on synthetic division, we went over this because when we divided x cubed minus 2x squared plus x minus 1, we found out what the quotient was, but we also found out what the remainder was. The remainder was equal to negative 5 when we divided it by x plus 1. So that's kind of a correlation there. Using the remainder theorem, we're not able to find out what the quotient is, right? We don't know the coefficients on the quotient when we divide this by x plus 1, but we know that the remainder is going to be equal to negative 5. Okay, let's do another example here. What's the remainder when x to the 5th minus x to the 3rd plus 7x squared plus 4x minus 16 is divided by x minus 1? So this long ugly thing here is our function, and we're dividing it by x minus 1, our linear factor. Okay, so x minus 1, right? If we're dividing by x minus 1, then that means that the remainder r is going to be equal to the function evaluated when x is equal to positive 1. Because remember, we have to flip the sign of whatever we're dividing by. So f of positive 1, that's just going to be positive 1 wherever we see x. So positive 1 to the 5th minus positive 1 to the 3rd plus 7 times positive 1 squared plus 4 times positive 1 minus 16. Okay, 1 to the 5th is 1 minus 1 to the 3rd, which is 1, plus 7 times 1 squared, which is 7 times 1, which is 7, plus 4 times 1, which is 4, minus 16. Okay, in the first two terms, we see 1 minus 1, so those cancel. Now we have 7 plus 4 minus 16. So 7 plus 4 is 11, minus 16, that's going to be negative 5. Okay, so in this example as well, the remainder is also negative 5. That's just a coincidence. Okay, so if we're dividing by x minus a, in this case it was x minus 1, then the function evaluated at a, function evaluated at 1 in this case, is going to be equal to the remainder. Okay, we don't know what the quotient is, but we know what the remainder is. Okay, fully factor x cubed minus 3x plus 2. So this might be a bit confusing because in the last examples, it said find the remainder. And in this one, it's saying fully factor this expression. Well, we have to go back to what I talked about at the beginning of the video where I talked about the factor theorem. So we know that if we have some function f of x, and it's being divided by x minus a, right, the remainder is going to be equal to the function evaluated at a. But I also said that x minus a was a factor of f of x if f of a was equal to 0. Right, so the first thing we have to do to try and factor this thing is think of what numbers can we plug in for x where this whole thing is going to become 0. Okay, so you'll remember if we have, for example, like x plus 1, x minus 5, x plus 3, right? This last number here, the constant, in this case it's plus 2, is just this positive 1 times this negative 5 times this positive 3. So this is negative 5 times positive 3, which is negative 15. So for this function, the last number would be negative 15. But when we're trying to factor expressions like this, we have to look at this last number, this positive 2, and think, okay, which numbers multiply to positive 2? Okay, so if we have our number positive 2, we can split that up into 2 and 1, right? And we can split that up into negative 2 and negative 1. Okay, so it can be plus or minus 1, plus or minus 2 as our factor. So that's kind of a list of the possible factors of this function. So I'll go plus or minus 1, plus or minus 2. because different combinations of these multiplying will give us this last number, positive 2. Okay, so let's try them. Let's see what happens when we plug in positive 1 for x. Well, 1 to the power of 3 minus 3 times 1 plus 2, that's going to be 1 minus 3 plus 2. That's going to be 0. So when x is 1, okay, when x is 1, the remainder is equal to 0, or the function value is equal to 0. Well, hold on. The factor theorem says that if the remainder is equal to 0, then that must mean that what you put in is a factor of the function. So if x is equal to 1, that means when we divide this, one of the brackets must be x minus 1. Okay, so if we know that x equals 1 is one of our factors, right, is one of our zeros of the function, or it's not a function in this case, but we can think of it as a function. So if we know that we're going to start with x equals 1, that kind of checks the box. Let's use synthetic division. So if we know x minus 1 is a factor of this thing, using the factor theorem, we can use synthetic division. So we have x cubed, so 1x cubed. We don't have any x squared, so we jump from x cubed to just x, so we're going to put 0 here because it's 0x squared. And then we have minus 3x plus 2. Okay, and then x was equal to 1. In this case, we're going to put 1 here, and we're adding. Right, we always drop the 1, so it's a 1 here. Then we're going to go 1 times 1, which is 1. And then remember, we're adding these two, so this is 1. Then we're going to go to this new number 1 times 1, which is 1. Negative 3 times 1 is negative 3. Or sorry, we're not timesing. We are adding. Negative 3 plus 1 is negative 2. Negative 2 times 1 is negative 2. And 2 plus negative 2 is 0. So remember, this last number here is your remainder. We already figured out that the remainder was 0, so that's not really any new information. But by using synthetic division, now we know what the coefficients on our quotient are. So we know that x cubed minus 3x plus 2, now we're kind of putting it all together, that's going to be equal to, well, one of our factors, or zeros, was equal to 1. So that must mean one of our brackets is x minus 1. Right? And the coefficients we have left over are positive 1, so positive 1x squared, and then another positive 1, so plus x minus 2. And what happens is if we expand all of this out, right, if we kind of rainbow everything in, we're going to get our original function x cubed minus 3x plus 2 using synthetic division. Okay, and we're not quite done yet, right, because we can factor x squared plus x minus 2. So we can think of two numbers that multiply to negative 2 and add to positive 1. But just to kind of keep the theme of synthetic division, let's keep going. So we know that one of the factors is x minus 1. But now that we know this is the new coefficient of the thing we're trying to divide again, let's do synthetic division again. Okay, so let's think of a number where our new function, right, is x squared plus x minus 2. Let's think of something where if we put in something for x, we're going to get 0 out of this. Well, if we did 1 again, we would get 1 plus 1 minus 2. That would work. So if we did 1 again, right, we'd also get a remainder of 0. So remember, we carry down the 1. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. Negative 2 plus 2 is going to be 0. Right? So this is our, this is what we're left with. Okay. So we got 1, yeah, we got 1, 2, minus, okay, cool. So now what we have is our original expression is going to be equal to x minus 1, the thing we divided by the first time, and then we divided by x minus 1 again using synthetic division. So x minus 1 here once again, and then the coefficients we're left with are x and then plus 2. Okay, so this is essentially what the function is. We just factored it. And x minus 1 times x minus 1 is x minus 1 squared times x plus 2. So you can write it either way, but this is the fully factored form of our original expression, x cubed minus 3x plus 2. So remember, you always look at this last number here, the constant. In this case, it was 2. We think of everything, every possible combination that can multiply to positive 2. So positive 1, negative 1, positive 2, negative 2. We try plugging all those numbers into to the expression. If any of them equals 0, that means that that's a 0. It's a factor of the expression. So in this case, we plugged in positive 1 for x, found that equals 0. If x is positive 1, the bracket, the factor must be x minus 1. We use synthetic division, right, to get the coefficients of our new quotient, right? And we realized we weren't done, so we did synthetic division again, plugged 1 into this new quotient, found that equaled 0. So our remainders were 0 in both cases, and we just kept going. And we found that x minus 1 was a factor, x minus 1 again was a factor, and we were left with just x plus 2. So our final product, right, is going to be x minus 1 squared plus 2. So even though we use synthetic division, we didn't divide this function by anything. We just used the factor theorem to figure out what the factors of x cubed minus 3x plus 2 were. Okay, let's do one more example. So this one here, remember we always want to look at this last number, negative 30. Okay, so when we're thinking of factors of negative 30, right, we always do plus or minus 1. That's kind of the first one we think of. 30 can be divided by 2, so plus or minus 2. 30 can be divided by 3, so plus or minus 3. 30 can be divided by, no, it can't be divided by 4, it can be divided by 5. And it can be divided by 6. Not 7, not 8, not 9, but it can be divided by 10. And 15. I'm running out of room here. And also plus or minus 30. So I always like to start out with the smallest numbers as possible. So let's try positive 1. If we plug in positive 1 to this expression, we get 2 times 1 to the 4th minus 15 times 1 cubed plus 24 times 1 squared plus 11 times 1 minus 30. So I just plugged in 1 wherever I saw x. 2 times 1 to the 4th is 2 minus 15 plus 24 plus 11 minus 30. So this will be negative 13 plus 35 minus 30. We're going to get, let's see, negative 43, so that's going to be negative 8. This isn't equal to 0. So the function evaluated, if this was a function evaluated at 1, does not equal 0. Therefore, x plus, x minus 1 would not be a factor of this expression. So we're going to move on to negative 1. We already tried plus 1, let's try negative 1 now. So instead of putting a positive 1 in where we see x, let's put a negative 1 in. See if that makes a difference. Okay. So 2 times negative 1 to the 4th, well, negative 1 to the 4th is negative 1 times negative 1 times negative 1 times negative 1. That's going to end up being a positive. So it's going to be 2 times positive 1. And then we're going to get minus 15 times negative 1 cubed. That's minus negative 15, right? Because negative 1 cubed is negative 1. So we're going to get 2 plus 15. And then we're going to get plus 24 times negative 1 squared, so plus 24, plus 11 times negative 1, so minus 11 minus 30. So we're going to get 17 plus 24 minus 11 minus 30, which is 41. We're going to get 41 minus 41, so that is going to be 0. So it seems that when we plug in negative 1 for x into this expression, we do get 0. Our remainder is 0. So that must mean that if x is negative 1, then x plus 1 is a factor of this expression. X plus 1 is a factor of this expression. Okay, so now let's use synthetic division to kind of keep going. If we know that x plus 1 is a factor, right, we're going to do negative 1 for our number on the side. We're going to be adding. And again, you can do positive 1 and subtracting, but I just prefer adding. Right, so this is going to be our coefficients here. 2, negative 15, 24, 11, negative 30. Okay, bring it down this 2. We get 2 here. 2 times -1 is -2. -15 plus -2 is -17. -17 times -1 is +17. 24 plus 17 is 41. 41 times -1 is -41. 11 plus -41 is -30. -30 times -1 is +30. And our remainder here is 0 because -30 plus 30 is 0. Okay, so these are the coefficients on our new expression. Okay, so I'll call it a function even though it's just an expression. So our function f of x is x plus 1, our original factor, times the quotient, which is left over. So 2x squared minus, or this is actually a cubic now, 2x cubed minus 17x squared plus 41x minus 30. So notice how we're not done factoring, because we still have an x cubed, x squared, all this stuff. So let's do exactly what we just did, but just with this part now. So can we plug anything in for x where it's going to equal 0, our remainder is going to equal 0? Let's try 2, x equals 2. That's kind of the next number, right? We already did plus or minus 1, so let's try 2 now. Well, if we plug in 2 into this part here, we're going to get 2 times 2 cubed minus 17 times 2 squared plus 41 times 2 minus 30. Well, 2 times 2 cubed is 2 times 8, which is 16, minus, that's an ugly 17, minus 17 times 4, which is, oh goodness, 68. Okay, so minus 68. Plus 41 times 2, so plus 82, minus 30. Okay, I got to do a bit of thinking here. I don't have a calculator with me, so this will be 16 plus 82 is 98. So 98, and then we got negative 68 minus 30, which is negative 98. So we're going to get 98, 98, which is 0 if we subtract them. So x equals 2 is a 0 of this function. So x minus 2 is indeed going to be a factor. Okay, so if x is positive 2 for our number here, we're going to go plus, and our new coefficients are going to be 2, negative 17, 41, and 30. So 2, negative 17, 41, negative 30. Okay, bring down the 2 as always. 2 times 2 is 4. Negative 17 plus 4 is negative 13. Negative 13 times 2 is negative 26. 41 plus negative 26 is 15. 15 times 2 is 30. Negative 30 plus 30 is 0. So like we suspected, our remainder is 0. And now these are the new coefficients on our function here. So remember, we divided by x plus 1 to start. Right now we're dividing by x minus 2. Right, so our function f of x, now we know, is equal to x plus 1, our first factor, times x minus 2, our second factor, times these new coefficients, which is 2x squared minus 13x plus 15. Okay, and we can do synthetic division again, with whatever method we want, right? So we can try, I don't know, instead of doing synthetic, let's actually factor this how we know to factor quadratics. Okay, to kind of mix up our methods here. So we got x plus 1, x minus 2. If we're factoring 2x squared minus 13x plus 15, remember we multiply the 2 and the 15 together to get 30. And then we think of two numbers that multiply to 30 and add to negative 13. Okay, so that's going to be, let's think here. So 6, that's not going to be no. This method might not work, but it might. So negative 13, we're doing all that right, yeah. So the factors of 30, we got 6 and 5, 15 and 2, but that's not going to work. So maybe what we have to do is split this into 2x and x, and after that, we know the two numbers have to multiply to 15. So this is probably going to be, let's say we can try doing minus 5, right? And then this would have to be 2x minus 3. Let's see if that works. So 2x times x is 2x squared, right? And then we got 2x times negative 5 is negative 10x. Negative 3 times x is negative 3x. Yeah, that looks good. And then plus 15. Okay, so now this is fully factored. If we wanted to find the zeros of this thing, right, the zeros would be x is negative 1 from this first one, x is positive 2, x is, if we set this equal to 0, 3 over 2, so 1.5, and x was equal to positive 5. So if you put in negative 1, 2, 1.5, or 5 into the original expression, it'll just be equal to 0. And that's because the factor theorem tells us that if we evaluate a function at one of its zeros, our remainder is just going to be 0. Okay, so those are some heavier examples for sure, but like I said, synthetic division is super necessary when we're doing stuff like this. So we can take super kind of higher degree functions or expressions and factor them by synthetic division or by factoring by grouping, long division, that kind of thing. But synthetic division is my favorite method to use, probably just because it's so quick. I hope this was helpful. I know it's kind of confusing stuff, so message me, shoot me a comment if you have any questions, and yeah, thanks for listening.